compiled Python files. So in this video, we're going to bring you through the concept of a compiled Python file in 2 steps. So we're going to talk about what is Python bytecode and how can we take a look at bytecode. If we start importing third-party modules, we're going to see that in our directory, along with the .py files, we see some .pyc files. So .pyc files represent or is a short form of Python compiled files. And the difference between .py and .pyc files is .py contains code or Python code that we create. They need to be interpreted at runtime, which means that they're slow. What does this really mean? So what happens is when we go into our WinPython PowerShell and we invoke the command Python file, what happens is the Python interpreter, i.e. the command that we're giving PowerShell, will then open the file that you have fed in the second argument and starts executing all the code there. When a program dynamically or real-time interprets your Python code and executes it in your local operating system, that's called interpretation or real-time interpretation, where that process is quite slow, and doing this at runtime means that your Python program is not very efficient. So Python does something very smart. What it does is it generates a compiled bytecode version of your Python file. So all you need to know about this is this bytecode thing is the way that Python talks to your computer. So the same way that you talk to Python in terms of, okay, Python print hello world or Python add 1 to 1, Python itself talks to the operating system, so things can appear on screen and it could access the CPU and all that kind of stuff. So the way or the language that Python uses to talk to your machine is called bytecode. And this bytecode, because it's slightly more complex and low level than your Python code, it's faster. When Python interprets your Python code in runtime, what it's actually doing is transforming the code that we know as Python into bytecode so they can then use it to talk to the operating system. By compiling this bytecode and then storing it on disk as PYC files, it avoids interpreting your code again and again if you run the same program twice and you haven't changed the code. So PYC files come by in this way. It's automatically generated by the interpreter and it speeds up future executions. It's actually only created from a .py file if it is imported by another py file or module. So you don't always see PYC files, but if you do see them, now you know what's happening. Now a very good point of curiosity is how can we see what the bytecode looks like? So there's this command, which I'm going to show you now. So we're back in our IPython and let's just define a very simple function and see what the bytecode is. So consistent with the theme of this day, we first need to import dis, which stands for disassembling, and we disassemble our Python code and see what the bytecode says. Let's give something to dis so that it could disassemble. Let's define a very simple function, hello world, and this function simply prints hello. Right, so we know what this means. We define a function called hello world taking no inputs, and we print simply the string hello world. If we execute hello world, we should get print hello world. Very easy. To create the bytecode representation of this, we can do this.dis hello world, and it will show us a bunch of mumbo jumbo. So there's no reason to be scared of what's happening here, but it tells us that hello world is internally represented as just prints and hello world, and you have things like load global, load constant, call the function, pop the top, load the constant, and return a value. So these roughly mean something to us, as in the words make sense, but it probably doesn't make a lot of sense as a whole to everybody. All you need to know is this is what bytecode looks like, and as you can see, for something as simple as printing hello world, this has a much more complicated value underneath when we need to get the Python interpreter to talk to the operating system directly. And that's why interpreting things real time is slow, because Python actually needs to change this into this before it can do anything. And then if it saves all of this bytecode in the PYC files, and the next time you run it, it can directly invoke this code and use this to tell the operating system what to do instead of reinterpreting what this means in this context. That's all there is to it. So I wanted to talk about Python bytecode because it's created whenever we import third-party modules, and we need to import third-party modules for this exercise using requests and Beautiful Soup 4. And so under this, Python is going to create some PYC files, which I want you to understand what it is, and it also allows you to appreciate how Python actually works and helps you build a good fundamentals and foundation to understanding when you're a more advanced Python programmer. I also showed you how we can look at Python bytecode. What we do is we import the module dis, and then use the function within the namespace dis to disassemble a particular function. It would then show us the bytecode involved in this function. In the next video, I'm going to talk about how we can use Python packages. I'll see you guys next time.